So, right, I guess we can get started. Can you hear me well? All right, cool. So, good morning, everyone. Thanks for coming. My name is Mesut Durukal. I'm originally from Turkey, but I'm living in Japan for about 5 years. So, as expected, I'll talk about robots. Anyone from Japan? No one? Anyone developing robots? A few people. Testing robots? Okay, no worries, because you will find something relevant. We'll talk about what kind of relevant topics, especially for testing, okay? Because I will share some challenges for testing this project. What I'll talk about is a warehouse management. Like we have a warehouse where some items are stored, and we are supposed to test this system. Like everything should work as expected and work efficiently, because I'll talk about this, but efficiency is very important in a warehouse because we are trying to complete the orders. Some orders are having some priority. So this will be some challenges. Very few of them are very specific to this project, but I'll list almost 10 different challenges. Most of them are applicable to any testing project. Like we will talk about test maintainability, recoverability, those kind of things can apply to any domain, any specific project. So first of all, I will explain this system under test, like how a warehouse can be managed by assistance of robots, autonomous mobile robots, AMRs. And I will explain our test activities, the test environment, and what kind of activities we are doing before going production, before going to real warehouses. And then the third part will be the biggest part, 10 different challenges. And of course, since we are talking about some problems, we will talk about solutions as well. And then we will wrap up. So, a little bit warming up about my background. I'm not working for that company anymore, but the first company I was working in Japan was a robotics company. They sent me an offer, and by the time I was living in Turkey, Japan, no, like, what can I do in Japan? This is what I was thinking. Then I thought, maybe why not, right? I can just give it a try. And this was my imagination, like robots everywhere. Japan is a super developed country, digital industry, everywhere is very advanced technologies. This was not 100% true. Like, these are true, all of these images, by the way. They are not AI generated. They are all, the first one is Shibuya, the second is in a fair, I guess, in Nagoya. The third one is, I guess, somewhere called Shinjuku. The last one is Odaiba, the huge robot. You can imagine the size compared to the humans next to the robot. But in real life, like Japan is a super cool place, like where the past and the future meets. The first place I rented my house was called Ryogoku. It was just 5 distance, walking distance from the sumo stadium. So my neighbors were sumo wrestlers. And when I, early morning, go to the street, I was seeing some sumo wrestlers doing some scratch practices on the street. And the first time I saw a sumo wrestler riding a bike was a shocking moment for me. Like, I mean, I couldn't understand what's happening over there. A wrestler was moving, a huge guy. And then I realized there was a bike under him. So, but not only that, like you can see people wearing kimonos on the streets, like having a tea ceremony in a temple. These kind of things are the part of daily life in Japan. But again, in the meantime, like these robots are really everywhere. So where can we see robots? They are not only in Japan, right? Of course, now they are everywhere. Like even now, 5 minutes ago in the exhibition area, I saw a robot playing chess with some guy. And yesterday I visited a Japanese restaurant. I missed Japanese restaurants in 3 days. So we saw this kind of in the third image, robot serving. Do you see this in Norway? Is it very common? Robots everywhere? Not that much common. In Japan, most of the restaurants are like this. You just order over the system and robots are serving the food. But of course, this is not the only industry, like in medical or the second one, the second image I saw in social media, I think it's a building in Oslo. So the full post was like a guy wearing sunglasses and cleaning the building. What she was doing is just controlling the drone while she had a beach seat and wearing sunglasses and cleaning the building in a cool way. So robots can help us in everywhere and in a warehouse. In the specific talk, we will see how they can assist us. First of all, let me help you imagine what kind of system we are talking about. In a warehouse, there are lots of different aisles where there are some racks, and on the racks there are shelves, and there are items. Suppose an order came and they said, we need, for example, 5 batteries which should be delivered to this customer. Okay, this is my order to be completed. So what I have to do is, I have to pick those 10 batteries from wherever it is, like in a specific aisle, in aisle A, in the third rack, on the top shelf, I can find this battery. For example, this is my location. I will pick, I will pack, and send to delivery. This is the mission. This is the order I have to complete. So you can little by little imagine the problem, the challenges. So there is a lot of walking for the operators. They will walk around different locations, and there is a carriage effort as well, especially for the heavy items. So this is where the robots are coming into place. Like they can already move to the relevant location and wait for the operators. In some robots, they even have some arms. They can even pick the items. But in this specific project, that's not the case. They don't have arms. So human operators should pick the items and put on the trays on the robot. So how robots are assisting is, first of all, they are minimizing the distance. They are making a calculation like, first, where should I go? Pick the first item or the second item? Because I'll a little bit more talk in detail about this, but this is not a super simple problem. Because in the meantime, I can have lots of different orders. And there are several robots that I can utilize. So maybe I can assign some orders to some specific robots, and some other robots are waiting in idle, so I can assign the rest to them. So this is an optimization problem. I'll talk about this. But mainly this is the mission and how we operate. So what are the components of this system? Of course, the robots themselves. This is the very fundamental component. AMR, as called autonomous mobile robots, almost human size, like and it's configurable. Like on this specific example, we can see 2 trays, but you can make even 3 or maybe 1 huge tray. It's configurable. And on the bottom, there's a huge base where there are some sensors and some operating modules and trays and the screen. So on the screen, there's actually a UI application. This is just normal UI application, actually, just running locally on the robot. So yeah, that part on the top is a screen, and actually it's a touch screen, so you can interact with the system. As a human operator, when you go next to the robot, there's a barcode scanner as well, as you realize. You normally pick the item, scan the barcode, and then click screen for robot to let it go to the next location. This is how it works. So from the testing point of view, we can already imagine some case scenarios, right? It's just like a UI automation. So I'll show you what kind of tools we are using, but it can be just Selenium or any other UI automation tool. Next is the IMS, which is the inventory management system. The items, the item configurations, especially sizes, dimensions, because whenever we are talking about items, I should know the height, weight, and some other information so that I can calculate how many items I can put on a single tray or maybe I can use both trays on a robot so that I can calculate the number of robots I need for this operation. So this kind of information I get from the IMS. So this time, it's mostly the API interactions. So I request some queries, I perform some queries from the IMS, and I get the inventory information. For example, the battery from the first example I shared. Where is that? Which location? And what is the dimensions or the weight or the other information from these items? I can get all this information from the IMS. What else? HPC. H is the warehouse for me. Because from my system, I have several clients or customers. So they are based in different places. For example, in Tokyo, there are 3 different warehouses. In Osaka, there is another one. So all these warehouses are edges for me. And from an upper level, it will be the cloud PC. So I'll come to that point. But this node is an edge for me. And for each edge, for each warehouse, there's an HPC, which is the main controller. This is the brain of the warehouse. Whenever there's a new order, this module is making all these calculations and sending commands to the robots. Whenever a robot is assigned with an operation from the HPC, then the robot starts moving and going to different locations. And there are different screens where I can show the status of the robots. Like over there are 2 pie charts. One is showing the status of the orders, the other is status of the robots. And this, as I said, from an upper level, like whenever I need a new update, I don't have to physically go to Osaka, right? It is very far away. So I can just send the updates from the cloud platform to the edge nodes. This is how I operate in an upper level. And this is a general depiction of my testing environment. So again, as I briefly mentioned, there is the UI and the API interfaces. And from my test automation environment, I send my queries and I collect the responses and I perform my assertions to check the expected result is meeting with the actual results. So again, for this, I guess it is replaceable with some other tools like Cypress, Playwright, but by the time we were using Selenium. And for some other unit tests, there were some other frameworks like Google Test and some code written in C++. And of course, there were some interactions with the task management tools and the repositories that we were using. This is the general overview of test automation framework and the environment. And what kind of activities we were doing? Whenever we have a new request from a client, we have to go and set up the robots. But of course, if we right away go to the real physical environment and test, of course, we would have some issues, right? Nothing works on the first trial. So first of all, this is our testing environment in the company, in our building. So we had a reserved area. This is, we call it as alpha testing. I think in terminology, it can be used in different ways, like normally without including the real users or not. But how we use this term is like alpha testing is the in-house testing before going to real environment. And then beta testing in our terminology was doing the test activities in the real warehouses, but still without including the clients, not still as a user acceptance test. And finally, official user acceptance test was by the contribution of everyone. So you see there were some aisle numbers like A1, A2. So it was just a simulation of the real warehouse. But just to be able to detect the issues we might have in advance before physically going to some other real environment. So this was up to this point, this was just an introduction about the system and the test environment we have. So now we can talk about different problems while doing these testing activities. The first one, and probably the most challenging one, is the traveling salesman problem. I think it's a very common problem used in the terminology. which is like optimization of the distance that we have to cover, we have to complete, right? So I guess there is a simpler example here. I'll go back to the previous one, but explaining over this example is, for example, let's suppose there are 3 items I have to pick. And there are 2 options. Like if I take the first one in red, then which is first going to item 3, and then going back to which one? Item 2, item 1, and then the delivery point. Oh, of course, it is not the optimum one, right? Because first going to the closest to the delivery and going back, and then, but you see, this is just to simplify the problem. We have to optimize. And the more optimum one is, of course, starting from closer to the first operation start point, and then pick one by one, and finally reach to the delivery point. So how this problem looks in our daily operation is, again, normally we don't have only one order. We have lots of different orders to be completed. They are waiting in a queue, and some of them have some higher priorities. Some customers urgently need some items, so maybe we should prioritize that specific order. And in an order, let's say there are 100 items to be picked, and maybe I can use 4 robots, 5 robots, I don't know, there should be some calculation to do this. And eventually, is this an efficient solution or not? This is the problem. How I can ensure this? This is a difficult problem, right? Because again, if it is just like 1 minute lasting operation, it would be easier, but we are talking about a continuous operation in a daily range. So what we do is, not only instead of, but additional to the functional tests, we operate some longevity tests. Like during a day, it's not always the real operation, but by use of the simulation environments that we developed, we let the system run for 1 whole day. And at the end of the day, we check some metrics like order completion time, in what time we completed the orders, and the walking distance. Like operators, normally they have some sensors, and how much distance they made. Because this is an important problem. Because getting rid of, or at least reducing the manual human efforts is an important part of this system. And the number of human operators, like if the distance is minimized, then probably the number of operators will be reduced as well. These are the critical metrics. And eventually we check if using this system brings any benefit to this warehouse or not. Like we do some benchmark studies. What happens to this matrix if we don't use robots, any robots, 0 robots, and we check the number of distance? And then what happens if we use 1 robot? What happens if we use 5 robots? So this kind of benchmark study, and we provide a report to the warehouse managers so that they can decide how many robots they will use, or maybe they will not use the system if it's not beneficial for them. So this is how we try to verify the efficiency of the system. This is how it looks like from the camera in a warehouse. You see robots are moving and sometimes waiting for an operator to go to the next. And then you see when the operator arrives there, first she picks some items and place into the tray, and then clicks to screen and to let the robot go to the next location. This is an ordinary operation time in a warehouse. Moving on. Next problem, hardware in the loop. Like compared to a system which is pure software, of course, this is a little bit more challenging because there are too many surprises we can encounter. Like a sensor can send a weird signal or something can happen. Like whenever a robot is moving, there might be an obstacle in front of the robot. Who knows, right? This is a warehouse. This is a very dynamic environment. Some operators are moving in front of the robot. If the robot crashes to a human, then sorry, your project is canceled because this is a safety critical problem. Or there might be not a human operator, but maybe a box. Someone is carrying a box and puts on the ground and left. and when robot is trying to move, the aisle is blocked. So what should we do? Wait for block to be removed? No, but I have to find a new way, right? This is a new problem. So all these kind of things are the problems originated from the hardware interactions. So how we try to solve this problem is, of course, always trying to execute the test cases in real environments is not easy or not feasible. So we develop some simulation environments by use of robot operating system, ROS. You can see on the animation, like I can just dynamically place some obstacles. Here somewhere, I can, at some point, I can just put some and observe how the system reacts. Or on the right-hand side, I can still see how the system is continuing. And the paths are traced in different colors. So simulation environment helps a lot to understand the efficiency or the functionality of the system. Moving on. Of course, you didn't think that I would skip AI, right? AI is everywhere and in this project as well. So especially for testing, there are two buzzwords nowadays, testing with AI and testing AI. So this is mostly about the latter, testing AI, because whenever I'm doing my testing activities, I can use some AI systems that is testing with AI or with the help of AI. But how about if I have a system which is running with AI algorithms and I'm supposed to verify this? This is, I believe this is a little bit more challenging because like while developing the AI, of course, you can run some evaluation metrics studies and you can calculate the accuracy or different metrics. But how about from a functional testing point of view? Is AI working as expected or not? Or maybe is it possible that it can work in a more efficient way? That's also possible, right? For example, let me give you another example from another industry. Like now I'm working for a company which is doing developing job seeking platforms. So you make a query like in Oslo, find me the Java developer jobs. This is your query. So my system is running an AI algorithm to find similar queries, like maybe there is no Java developer position posted in Oslo, but maybe there is a Java software engineer position, right? So that is not exactly the same keywords, but in fact, it's a similar position, maybe even the same, so just with different words. So this is an AI algorithm. But how can I test if my system is returning really the similar ones or not? Is a more similar position Java software engineer or Java developer or Java engineer or whatever is the most similar? So that these kind of things are not very straightforward things to verify. So what we do, especially in this sense, is we are running some experiments. Like, for example, in robots, the AI algorithms are mostly trying to do visual recognition. Like there's a camera, and if there's an obstacle in front of the robot, is that a human or like a moving object or not? This is a classification problem. So these kind of AI problems are trying to be solved by the modules developed. So what we do is, again, do a lot of experiments, like put a cat in front of the robot and see how it's classified. Or put another object which is not moving to see if the system is accurately classifying or not. Moving on. Again, now we are moving to more generic problems, right, which can be applicable to any domain or any project, like usability. Especially in this project, as I mentioned in the beginning, usability is very important because if you are familiar with the factory or automation environment, industrial automation environments, seconds are even very important. Like if an operator is struggling to find where to click, then he's losing some time already. Not good. So the system should be usable and user-friendly. For example, like a lot of times, oftentimes we can see this kind of errors, right? Unknown error or system error, internal something error. I don't understand anything. Or what did I do wrong? Or what should I do to fix the error I made? No clue. If the system is returning an error, it should provide some helpful messages or instructions. Like, how can I get rid of this? What was wrong? And how should I find an alternative way to eliminate this problem? And again, in this sense, if the operators are not easily finding the locators or the elements to locate on the screen, then it will not be a good example for usability. Again, this highlights the importance of non-functional testing, right? Not only the functional, just running automated tests. Of course, that's an important part of the verification activities. But again, I will highlight this a few times. Non-functional tests like maintainability, recoverability, usability, a lot of abilities. Those are also very important. Yeah, recoverability. For example, what happens if somehow, so as you can imagine, there is a lot of communication going on in the environment, right? For example, robots are sometimes communicating to each other, or robots are talking to the HPC, and sometimes, not often, but sometimes edges are talking to the cloud PCs. So at any of these points, the connection can be interrupted. Like robot is not getting messages from the HPC. Then what will happen? It will be just stuck, wait for connection to be reestablished. Of course, that should not be the case, right? But what should happen is maybe just somehow continue the operation, and eventually, when the connection is remade, then the data stored in the robot should be again start to be transferred to the HPC. So these kind of scenarios are examples for the recoverability. Whenever something unexpected happens, how I can recover or manage this unexpected situation. And again, in normal daily life, it is not easy to hit these kind of problems. So what should we do? As you can expect, like there are different scenarios or activities we can do, like chaos testing, right? Intentionally put some modules down. Like one server is not responding, and observe how the system reacts. Can it manage by just finding some alternative ways to communicate, or somehow another way to manage the situation or not? And if not, of course, develop some action items to improve your recoverability, right? Next, moving on, reproduction of issues. Again, applicable to any CI/CD platform. Like you let your test run over the night, because all the time you are not sitting in front of the PC and trying to watch how the execution is going, right? That's not the case. We just let it go, and eventually we check the results. Okay, I checked the results and there's one failure. But why? I don't know what happened. It's not easy to understand right away. But I should do a debug analysis, right? I can go over all the logs. I can go over all the evidences collected during the execution, like maybe screenshots, even video might be very helpful. And I can try to understand. But only if I have all these collections during the execution. So for example, in any UI automation tool, you can get some screenshots at the point of failure, or even get some trace. For example, in Playwright, you can collect traces and you can replay. So similarly, in this project, in terms of ROS, there's a module called ROS back, and you can replay the collected evidences so that you can understand, even there's a video recording, so that you can understand at what point robot was stuck or the operation failed. But again, talking in a more generic way, in which we can apply to any testing project, collecting evidences and not losing them is very important. Like use a test management platform, and you can send your collections after executions, like not only the execution result, but also the logs, other materials you collect. You can upload them to the tool you are using, and then at some point you can go back and check. And even in this way, you can have a test history to even find the flakiness, right? For example, if at some point tests start to fail, then by checking all this test history, you can detect at what point it start to fail, and even the root cause. These kind of evidences will be very helpful. Moving on, customized requirements. What does it mean? Like I'm developing a system, but it will execute in different environments. So what's the problem about this? Will I modify my code or my test cases for each specific environment or the configuration set? No, that's not efficient, right? So what I have to do is try to develop some reusable tests. Okay, so extract the environmental parameters or the configurational variables from the test case itself, and then try to make the test itself reusable. So avoid duplication. Like this is a very well-known anti-pattern, right? If I have some hard-coded variables in the test code, then it's not good, because if the variable should be changed in a different set of configuration, then it will fail. Or maybe I have to change or update my test case for every point of usage of that specific variable. But if I have just maybe an Excel sheet or any other, maybe JSON file or any other configurational parameters, set of parameters, then that's the only point that I have to update. So it will improve the maintainability. So the key point there was trying to make use of reusability. Next is domain knowledge. When I was first hired for this company, I didn't know anything about warehouses. Time is flying, so I'll wrap up. But they were talking about something like some language that I don't understand. Like they were saying, okay, what happens if we use 2 totes instead of 3? What is totes? I don't know. Or they were talking about some operations which are happening in the warehouse. I didn't understand anything because I don't have to, right? So I can't know all the domains. I might be new to some of them. So to facilitate this onboarding, maybe customer visits, again, talking from a more generic perspective, whenever you are onboarded to a new project, directly talking to the end users will help you a lot. Like in this case, for example, go and talk to an operator. Do not stuck on your office. Or maybe if it's not possible, you can talk with online as well. But try to communicate to the end users, especially if you are a tester, if you are a QA engineer. It's very important. Because we should be the advocates of the users, right? End users. But how can I understand their struggles or their needs, their requests, change requests, if I'm not talking to them? So this is an efficient way which will facilitate your know-how and a perspective of looking to the product from their eyes. A similar one, technical stack, like the tools or the other components that you are using, tooling or the platforms. Then again, maybe preparing some onboarding documents, a documentation set which can help to the people which are just joining to the product or the project, will help facilitate this onboarding process. And finally, again, I briefly mentioned this, but avoiding duplication and trying to avoid code quality issues. Like on this specific example, I have 2 instances of the same image, right? Which is, I guess, Mona Lisa in this case. But why having 2 instances? Why not developing only one and replicating different places? So this is just an example for duplication, but there might be several code quality issues. So what can I do if we are talking about this problem? The solution should be, of course, peer review activities or even static code analysis tools, It might be maybe, I don't know, SonarCube, SonarLint, any or linting tools. They will help a lot. They will eliminate lots of very trivial problems and improve the quality. And in the long term, it might seem very simple, but in the long term, it will help you a lot to maintain the code. So let's wrap up. We went over 10 different problems. Very few of them were very specific to this domain or this system, but most of them are applicable to any testing activities, right? So we talked about the testability issues, which was not straightforward to verify. In this case, it was a minimum distance problem. And we talked about importance of non-functional tests on top of the functional tests. So longevity tests or benchmarking or performance tests. And we discussed hardware in loop, in which simulation environments that we are developing help us a lot. And we talk about testing AI, the difficulty, and we discussed how we can perform some experiments, again, on top of the functional verification activities. We discussed usability and user friendliness, how easily users can interact with the systems, right? And then we discussed about having an opinion from them, directly from them. This was also mentioned in the domain knowledge. But direct communication with the end users or the clients will give you a lot of insights about what they feel. Because for you, for developers or for the testers, you will already be familiar with the system that you are developing. But for end users, that's not the case. For example, you deliver a product, okay, please use this. So it's first time for them to use. Maybe they will not even know how to start, where to start, what to click, which flow to follow, right? So for you, it is trivial, but for them, it's not. So having an empathy or having their perspective is very important. So for that, maybe performing some user reviews, some interviews, talking to them, trying to understand at some points they are struggling is very important. Recoverability, we discussed about this, what happens if there is any unexpected situation, any communication issue in the system. And we discussed about the importance of chaos testing and reproduction of bugs, collecting evidences and analyzing them in the long term, especially for tracking the flakiness or the robustness of the test cases. How many times it's failing, how many times it's passing. If it's failing from time to time, then what's the root cause? For all this kind of analysis, you will need these evidences. Customization, different execution environments. We discussed about reusable test cases, separating environmental variables to make the code itself reusable. We discussed about domain knowledge, trying to directly see the operation environments. We discussed about importance of being familiar with the technical stack. And finally, we discussed about maintaining the quality of the code. Because sometimes, in most of the organizations I was involved, I remember these kind of discussions like test is not the end product, right? So do we really need code reviews for the test cases? How many of you have similar discussions? No one? Awesome. Oh, some of you, yeah. I mean, yeah, test is not the end product, right? But it is a product. There are some users using your tests. For example, there might be some other testers trying to understand what are the use cases of a test. Reading the test, executing the test, or writing new tests along with the test you already developed. Right? These are different use cases. So there might be some other testers or even yourself. Sometimes, personally, I don't understand the test I have written some time ago. Why? Because I didn't care about understandability, probably. So in the long term, you see the maintaining, if I need to update something on the code, because maybe the relevant feature is updated, right? We are embracing agile, okay, it's okay. But I have to update my test code relevantly. But I don't know how to update my test because first of all, I don't understand what this test is doing. It's not easy to understand. It's not easy to read. Readability, understandability, maintainability. All these kind of things are important code quality issues. So, last call for action. Please be aware of your problems. Define and analyze the improvement rooms. Do not hesitate to try something new. If it helps, then move on. If not, try something else, right? So try. And of course, share, communicate, and collaborate with others. So we always say holistic work, right? Teamwork. Quality is not something that we can perform individually. Okay, these are good sentences, but in practice, if we are really sharing these problems, talking with lots of different teams to understand what kind of problems they are having, this will, in practice, give us the chance to perform a holistic work. So yeah, if you are interested more in more materials and references, this is the website that I found, most of them, so you can go and check. And yeah, that's it. If there is any questions, I'm more than happy to answer. Thank you.